Okay, guys, here's the dimensional analysis that we did. What I need you to do, if you don't have it right now, make this table or find this table and make the adjustments that I made here. Okay, modify it like how I did. So in front of each line, put a 1 all the way down. And then in each line, put an equals right here. Okay? Make sure you have these symbols as well. Okay, this is the micro. This is how you make the micro. Okay, it's like a bar with a U. Okay, it's a U, and then an extra bar in the front. Okay? All right, once you got it, you can unpause. All right, make sure you got this down too. 2 times 10 to the third meters equals how many centimeters? All right, when we're doing a problem like this, the first thing you have to do, the very first thing, most important, make a conversion factor. Make a conversion factor, please. Here's why. It's going to tell us how to do everything. Okay, what is a conversion factor? It's a something equals something statement. Okay, something equals something statement. You know what a conversion factor is. You've seen them before. If not in my class, you've seen them somewhere. So dollars and quarters, right? You got 4 quarters equals $1, right? You know this, right? This is a conversion factor. Something equals something. It's something that helps us convert, all right? So you got to have it. Okay, so let's do it. Let's make a conversion factor. You got this cool table right here that you did. Let's read it. 1 nanometer equals 10 to the negative 9 meters, okay, or grams or seconds, whatever. 1 micrometer equals 10 to the negative 6 meter. 1 millimeter equals 10 to the negative 3 meters. 1 centimeter equals 10 to the negative 2 meters. 1 kilometer equals 10 to the third meter. All right, so you see what we just did? We just said 5 conversion factors, all right? Which one of those do I need for this problem? Let's see. Meter. Do I see meter here? No. But I see centi, right? Prefix centi. Here's centi. Let's read that sentence. 1 centimeter equals 10 to the negative 2 meters. So I'm going to write it exactly how I said it. 1 centimeter equals 10 to the negative 2 meters. Don't worry about that long squiggle. Okay? All right, see how I made a conversion factor by just reading it left to right? 1 centimeter equals 10 to the negative 2 meters. All right. That's really, really important because it's going to tell us where to put our numbers in a second. All right. So if I want to get rid of meters, I got to cancel it out by putting it on the bottom, right? Top, bottom, just like algebra, we cancel it out by dividing, right? Okay. So that's going to get to cancel. It's a lot of fun. It's going to cancel. Bam, cancel. All right. Okay. Now, where do I put my numbers? Well, look here. I got my conversion factor. It tells me exactly where the numbers belong. So you see this meter unit right here? Right in front of the meter unit, I got 10 to the negative 2. So see 10 to the negative 2 meter. This needs to say 10 to the negative 2 meter as well. Okay. What about up here at centimeter? Well, 1 centimeter, 1 centimeter. I got all my information for making this conversion factor. That's why it's the most important step. It's the first step. All right. So now look at what I got. I got 2 times 10 to the third times 1. And then look, it's under the bar, so divided by, under the bar, divided by 10 to the negative 2. Okay, so on my calculator, I'm going to type it like this. 2e3, and then what's the divide? It's a bar, right? It's a bar, all right? And then how do I type 10 to the negative 2? I just do e negative 2, all right? Let's see what I get when I put that in the calculator. 2e3, and then divided by e negative 2. Make sure you use the little negative. If you use the big negative, you're going to get a syntax error. All right, so I got 200,000. 200,000. And that's centimeters because look, we're canceled out. Meters canceled out, and I'm left with centimeters. If you have it in scientific notation, that would be 2 times 10 to the 5th. Okay, 2 times 10 to the 5th. So either answer is fine, as long as you have the unit. But either answer is fine in this class. Just make sure you have the unit either way. All right, good. Let's do one more. That's kind of like that, but a little bit different. All right. So let's say I had 100 seconds equals how many milliseconds? So ms. M is milli, s is seconds. All right. Okay, cool. So let's put my bars there. We're always going to do train tracks on this, just to kind of help us organize our math here. All right. So again, what is the very first step I have to do? I have to make a conversion factor. Blow it up, make a conversion factor, right? That is a something equals something statement. This time, let's see, I got seconds here and milliseconds here. All right. Where's my seconds? I don't have the seconds prefix, but I do have milli, right? Look at milli. All right, milli, let's read it. 1 millisecond equals 10 to the negative 3 seconds. 1 millisecond equals 10 to the negative 3 seconds. All right, let's write it just like I said it. 1 millisecond, I'm just going to write it right on here, equals 10 to the negative 3 seconds. I'm just going to grab this guy. Yeah, come on down. All right, that's my conversion factor right there. Okay, this is super important, right? Because it tells me how to put all these things down. Okay, what am I canceling? I want to get rid of seconds, right? So seconds has got to go on the bottom, right? All right, so cancel this guy out. Okay, remember, I know where to put my numbers because I'm reading this. 10 to the negative 3 seconds, right? 10 to the negative 3 seconds. 1 millisecond, 1 millisecond. Cool. I put this in the calculator like this. 100 divided by, probably put parentheses around that, e negative 3. Let's see what I get. I already know what I'm going to get, but I'm typing it anyways. 100 e negative 3. All right. We get 0.1 millisecond. That doesn't make sense. What happened? You guys see what I did wrong? Oh, okay. Yeah, I multiplied my calculator. That's dumb. 100 divided by, there it is. Second, okay, e negative 3. All right. There we go. That's more like it. Why did I get 0.1? Okay, so you gotta kind of think too. I shouldn't get a small number because a millisecond is a thousandth of a second, right? So if I have 100 seconds, I should get a whole lot more than 0.1 milliseconds, right? So that was dumb, right? If you ever put something like that wrong in your calculator, you put 0.1, I mark it wrong. I'd be like, that's wrong. But guess what? I'd look at your math and be like, okay, that's right. This is right. This is right. This is right. Look, you're getting 75% of the problem right. No, you're getting 80% of the problem right. So you just got 80 points out of 100 on that. So that's just one problem, okay? So even if that happens to you, make sure that's why you show your work. So you don't do what Mr. Bayona just did. All right? Is that cool or what? All right, so let's erase this guy. When I put that in the calculator on the reals, let's see, I got 100,000. All right, 100,000, which is milliseconds, which makes a lot more sense. Okay, and that's 1 times, that's nasty. All right, 1 times 10 to the 5. See how I counted the decimals? I cheated. Okay. Cool. You can put it in scientific notation, or you can put it in the standard form if you want. Either answer is fine for this class, but it's just kind of obnoxious after a while. So, cool. If you have any questions, please let me know. Bye-bye. Bye.